So in this video, we're going to take a look at surface area of similar solids. So kind of how can we compare the surface area from one solid to another as long as we know they are similar to each other. So if a solid X is similar to solid Y by a scale factor, then the surface area of X is equal to the surface area of Y times the square of this scale factor. So that's a very, mathy definition there. But the idea here is I know that these two solids are similar if I look at these two because I have 4, 4, 4. This is a cube. And then I have 8, 8, 8 for my length, my width, and my height. Well, as long as the sides are proportional, then they are similar. So they're not identical. One is definitely smaller than the other because this 4-inch cube is smaller than the 8-inch cube. Hopefully we can see that. But they're proportional. I would multiply each side by 2 here, and I would get this larger cube. So they are proportional to each other, meaning they're similar. Okay, and they're the same shape, obviously, right? They're both cubes. So now I can find the surface area of one and apply that to the surface area of the other. So if I do the surface area of the small cube, so this little one here, I have the area of one face times the number of faces, because if I have one face, well, they're all going to have exactly the same area because that's the idea of a cube. It's made out of 6 identical squares. Okay, so I'm going to take the area of one of the faces, which is going to be 4 times 4, and then I'm going to multiply that by the number of faces I have, which is 6. So 4 times 4 is 16, times 6 gets me 96 inches squared. So this is the surface area of the small cube. Just one of the faces. I just did, you can even look at this one where it's length and width. So I did 4 times 4, and then I just taking into account, I know that I have 6 faces that are all exactly the same. So I'm just going to multiply by 6. All right, so if I want to do the large cube, I can take the surface area of the small square, or the small cube is what that should say, and multiply by the scale factor. So I can just multiply by the scale factor squared to get from this cube to this cube. If I know I have to multiply the side by 2 to go from 4 to 8, well, if I'm going from area, I'm going to take the area and I'm going to multiply by that scale factor, which is 2 squared, because I have to take into account that two-dimensional idea for area. So here's the area of the smaller one. Now I could have just inserted the 96 inches squared because we already did that part, right? That's that 4 times 4 times 6. And then I'm going to multiply that by 2 squared. Okay, so we're taking 96, that's this first part, the 4 times 4 times 6, and I'm going to multiply by 2 squared, which is 4. So 96 times 4 is 384 inches squared. All right, so the volume of similar solids. If solid X is similar to solid Y by a scale factor, then the volume of X is equal to the volume of Y times the cube of the scale factor. So we're thinking about that exact same scenario we just went through with the area, the surface area. Well, we can do the same exact thing with the volume, but volume is a 3-dimensional measurement. So now we're not going to square the scale factor, we're going to cube it to take into account that 3-dimensional idea. So we're going to find the volume of the small cube, we simply have to do one of the sides cubed. Because if we think about the volume of a rectangular prism, even though this is a cube, it would be length times width times height. Well, since they're all exactly the same, it's 4 times 4 times 4, that's the same thing as saying one of the sides cubed, okay? So in this case, we're going to go 4 cubed, and we're going to get 64 inches cubed. Remember, we want to make sure we always pay attention to what unit we're putting on there. The volume of the large cube is going to be the volume of the small cube times the scale factor cubed. So here's the small cube again, 4 cubed, and then times 2 cubed. So remember, this was 64. Well, 2 cubed, that doesn't mean 2 times 3. It means 2 times 2 times 2. 2 times itself 3 times, which is 8. So now I'm going to go 64 times 8, and I get 112 inches cubed. All right, so now we're going to take this. We're going to apply it to a problem here. So we're going to have a designer builds a model of a car. The finished model is exactly the same shape as the original, but smaller. The scale factor is 2 to 11. Okay, so the model, if it's 2, say it's 2 inches, then maybe the real car is, I don't think you'd say 11 feet. That'd be a big jump there, but it's 2 to 11. okay, for from the model car to the actual car, okay? So find the ratio of the volume of the model to the volume of the original. Then they want us to find the ratio of the surface area of the model to the surface area of the original. And lastly, they want us to find the ratio of the height of the model to the height of the original. And write the ratios in the format M, N, okay? M to N, like this. So they want us to write it in this format with our little colon, okay? So for the first part, we know what the main scale factor is. It's 2 to 11. That's the scale factor of basic lengths, widths, heights, things like that. Okay, perimeter, if they asked you for something like that. If we want to know volume, we're going to take that scale factor, and volume is a three-dimensional measurement, so we are going to cube it for volume. Remember, because it's three-dimensional, so we're going to cube it. So we're going to take that 2 over 11, and we're going to cube both the top and the bottom. So it's 2 cubed, we just did that on the last page, that's 8. And then we're going to do 11 cubed, which is pretty big. 11 times 11 times 11 is 1,331. So this is the ratio of the volume of the model to the volume of the original car. Okay. Now, the second thing they ask is for surface area. Area is whether it's surface area or just regular area, it's a two-dimensional amount, right? Two-dimensional measurement. So we will square the scale factor to take into account that 2 dimensions. So we're going to go 2 over 11. We're going to square. So 2 times 2 is 4. 11 times 11 is 121. So that's our ratio for the surface areas. And now we're going to take into account the heights. Now remember, that's just a regular old length. There's nothing super special about the heights. We don't have to square or cube it. We just have to take the original scale factor, because height is a one-dimensional amount. It's just how long is it? So we will keep the scale factor as it is, which is 2 over 11. So now we're going to take a look at actually computing a side length, surface area, and a volume for similar solid. So not just the scale factor, but we're going to have to apply that scale factor idea to find an actual missing measurement. So here we have 2 similar cylinders, have diameters as shown. So we have one with a diameter 7 and one with a diameter of 6. So they are showing us that they are similar, okay? Or they told us that they're similar. So if the surface area of cylinder on the left is 588 centimeters squared, find the surface area of the cylinder on the right. And then they're also going to have us find a height that's missing from one and a volume that's missing from one. Okay, so before we jump too far into these, we do need to know, okay, what scale factor? Because they didn't actually tell me scale factor up here, right? Well, they did. They just told it to us down here in the measurements. So they said in the diameters as shown below. So I have my scale factor. If I look at the cylinder on the left to the cylinder on the right, it's going to be 7 to 6. So this is my scale factor, okay? And so the very first question they ask me is to do surface area. Well, remember, I have to take that scale factor and I have to change it if it's area or volume. If it's just the length, I leave it alone. But since it's an area, I'm going to have to take that scale factor and I'm going to square it. So I'm going to have 7 squared, I'm going to have 6 squared. So 7 squared is 49 and 6 squared is 36. So this is the scale factor ratio for my surface areas. So I'm going to take that and I'm going to apply it to the information they just gave me. So I know on the left, the cylinder on the left here has a surface area of 588 centimeters squared, and we don't know what the surface area of the one on the right is. That's what they want us to find out. So we're going to take our scale factor, which is 49 over 36, and we're going to set that equal to our ratio for the 2 cylinders. So 588 over question mark. Now remember, I still have them in order. 49 over 36, this was the one on the left to the one on the right. This is the one on the left to the one on the right. Make sure you're paying attention to that. You don't want to flip-flop that idea or you'll end up getting the wrong answers because you'll multiply the wrong pieces. So we're going to cross multiply now that we have a proportion set up. 49 times question mark. Well, that's just 49 question mark. Or I'm just squishing them together just like I would with a variable. And then 36 times 588. And I get 21,168. So definitely a big old number already. And now we're going to take that 49, I'm going to divide by 49 on both sides. Okay. So now if I divide 49 divided by 49 is 1, and I'm going to divide 21,168 by 49, and I get a nice even number there, 432, centimeters squared. So that's my surface area for this cylinder on the right, the smaller cylinder. So now I'm going to do, if the height of the cylinder on the left is 14 centimeters, find the height of the cylinder on the right. So now I kind of cleared things out a little bit so you can see it. So here we have a height of 14 centimeters. I don't know what the height of this one is. So height is just a regular old measurement. It's just a length. So I'm going to go back to my original scale factor, and that's what I'm going to use for my first ratio. And I'm going to set that equal to the height that I know on the left to the height I don't know on the right. And I'm just using question mark again, because why not? That's our question. So we have 7 times question mark, which is just 7 question mark again, just squish them together. 6 times 14, and that gets me 84. Just like I did with 49 here, I don't want to know what 7 question mark is. I want to know what just question mark is. So I'm going 7 divided by 7, and I get 1. And then 84 divided by 7, I get 12. So the height of the smaller cylinder here must be 12 centimeters. All right, we have one more. It says, if the volume of the cylinder on the left is 1,029 centimeters cubed, find the volume of the cylinder on the right. So now we're going to take into account that we have volumes here. Now I know the scale factor of lengths, I know the scale factor of area, but now I need to do the scale factor of volume. I have to cube that original scale factor. So 7 cubed, that's 7 times 7 times 7, and 6 cubed, which is 6 times 6 times 6, we get some bigger numbers. So here it is, 343 over 216. So that's the scale factor I'm going to use on the volume. I know it's getting a little scrunched here, but hopefully that's all right. And that's going to equal the volume I know from the left over question mark for my right. So now, just like I did with the other ones, I'm going to cross multiply. All right, so I get 343 question mark. And then 216 times 1,029 gets me 222,264. And now I'm going to divide both sides by that 343 because I don't want that near the question mark, right? I want to move that over. So now I get 1 because 343 divided by 343 is 1. And when I divide by 222,264, I get 648 centimeters cubed. Now again, be careful. These units might already be on there for Alex, but if they're not, you need to make sure you're paying attention to the unit. If it's area, it's going to be squared because it's 2-dimensional. If it's a length, it's not going to have any exponent because it's 1-dimensional. And if it's volume, it's going to have a cube because it's 3-dimensional. So pay attention to those units. Make sure you choose the correct one when they make you do that. All right, so that is computing the side length and surface area or volume for a similar solid. I hope that helped, and I'll see you in the next video.